Alrighty, so the doors have closed, which is the universal symbol for it's time for me to start talking. So thanks for being here. It's already well into a very long week, so I appreciate you taking the time to join me today to talk about data science on an indie budget. So I'm Dr. Luke Dickin. I'm Director of Central and Strategic Analytics at Zynga, and today we're going to be talking about analytics, data science, and how to do it without it costing you an arm and a leg. So a little bit about me. I've been at Zynga for 3 years now. I started as a data scientist and kind of rose through the ranks through to kind of leading data science team, and then 2 weeks ago became Director of Central and Strategic Analytics, and then 2 days later pissed off on holiday. So I'm still not entirely clear what this new title means or what my job is, but I'll figure it out when I get home next week. Prior to that, I was a grad student doing a PhD in AI for games. I've actually got 4 degrees in AI. I set up a studio in the UK doing kind of work for hire AI stuff and working on our own games on the side. AI is kind of a theme for me. It's something that I've been passionate about since I was a teenager. So at this point, I've been kind of messing around with the field for about 20 years, which just makes me feel very sad. All right, so before we get started, let's address the elephant in the room. I'm talking about indie budgets, and I am clearly not that. Zynga's analytics department is spread across 4 countries. We're in the US, we're in Canada, India, and the UK. We have 10 years of institutional learning around how to do analytics in games. In fact, we kind of pioneered the idea of data-driven games back in kind of 2009, 2008, back in the Facebook days. And we also have, hold on, let's turn off notifications here, because that would be, or let's actually just kill that off, because notifications are off and it's still pinging me. That's awesome. And the other thing to keep in mind as well is not only have we been doing this for a long time, but we're doing this at a very large scale. Zynga has 19 million daily users across our entire portfolio, which is pretty significant numbers. And one of our biggest games is obviously Words with Friends, the new version of which, by the way, is in the Apple Store here in Australia right now. We're in soft launch in this territory. Feel free to grab it. But that does about 6 million daily users. So obviously this is operating at a scale that is not indie. So, how dare I come here and tell you how to do it as an indie, really? But what I want to really drive home is, okay, not everybody has those kind of resources. Not everybody has an operation at that scale and the kind of investment at scale. And for most of my career, I didn't either. I've only been at Zynga for 3 years. Before that, I was doing this stuff basically with no money at all. And the trick and the important thing that I really want you to take away from this talk is that this one is not going to be as energetic as that, whatever that is. The important thing is that analytics and data science are within reach for everyone. This does not require massive supercomputers. It doesn't require huge amounts of storage. It doesn't, well, it kind of does, but not beyond what we have on computers these days. Anybody could be doing this, and today I'm going to kind of show you a little bit about how and give you some pointers on where you can find more resources. So before we talk about data science, we're going to talk about analytics. Analytics is the foundation of data science. If you don't know anything about what's happening inside of your game, you can't figure out what's going to happen tomorrow, basically. So let's start off by getting into kind of analytics and how to go about figuring out what's happening in your game. So you start out and you maybe say, hey, some people are playing our games. And if you don't have analytics, then that's about all you can say. You can say, hey, Apple sent me a check, that's cool. But you don't know things like who, or how many people, or when. You can't answer basic questions like this about who is playing your game and how they're interacting with it. Basically, you can just shrug and say, meh, people. It's all good. It's not really a great way to run a business. So let's talk about how we might go about doing that a little bit better, a little bit smarter, and not sounding massively incompetent about the way that we're trying to make money. Because at the end of the day, analytics is actually for everybody on the team. And there is this perception, and it might have been a little, there's no cameras in here so I can say things, it might have been a little bit inspired by some of the way that Zynga operated back in kind of 2009, that analytics was seen as very much a dark side, kind of black hat technique. You know, it was about squeezing the last dime out of everybody. It's not really true. It's a little bit true. It's not all the way true. Because as an engineer, I could do with knowing who's crashing, where they're crashing, how are they crashing, what are they doing before they crash. So as an engineer, analytics and being able to understand what's happening in the game is super important for me. As a designer, analytics is super important for me as well. Like, how are people interacting with this? Are people clicking through in the way that we think they're going to? Are they using the features that we've designed in the way that we think they're going to? Are they kind of getting stuck in places? Is there something that we can do in the design to make things smoother? Well, if you just kind of throw something up on the App Store and go, meh, literally the only feedback that you're going to get is from Twitter and from reviews. It's not ideal. If you have analytics, then you can actually see where these problems are. You can see the problems in the funnel. If any of you were at the Unite talk we did on Monday, you would be familiar with the funnel and some of the issues that that kind of showcases. There's one coming up that I'll show you there. As a product manager or somebody in the more biz devy side, yes, I want to squeeze as many dollars out of as many people as possible, and analytics is going to help me do that. It's going to help me figure out what people are engaging with, where people might kind of be inclined to spend, maybe where we can kind of smooth things over, maybe we can surface an ad there, get a few extra cents. You know, it's about figuring out kind of what's happening there and kind of optimizing. As QA, analytics is going to be helpful. We talked about crash rates with the engineers. What about for QA? If they can actually see people did this, this, and this, and then this happened, that's a problem. Without it, you're reliant on the QA actually doing those things. With data, you're able to kind of say, okay, guys, this is what we think, figure it out. And even artists, and this is a bit of a stretch, but stay with me. If you were logging which assets people look at, or how much time they spend in certain menus, or playing with character models, maybe if you're thinking about like an RPG, spinning something around, you get a sense from the analytics then of what they're resonating with, what of your art is actually getting a good response. So even artists, you can kind of squint at it and say analytics could be helpful for artists. So when I say analytics is for everyone, I really mean absolutely everybody on the team can benefit from this. But you're an indie, maybe, or even if you're not an indie, you still want to do it cheap. You don't want to invest a huge amount of money in this, particularly until you start seeing the benefit of it. So how can you do it for cheap, or ideally for free? Well, you could build your own system, and I have done this. It was really not a good idea. But the way that you would do it is inside your game, whenever you want to log something, you generate some sort of HTTP request, whether that's like a web request in Unity or however Unreal does it. I'm sure they have a similar system, or whatever engine you're in. It's not hard to build a web request and fire it off. On the other side, what you need is a REST endpoint that's basically going to take that request, parse out all the bits that it needs to parse out, and shove it into a database. Again, it's not super rocket science. But then you need the back end, you need the database to actually store that data. You can do that. The problem that you have with all of this is now you're in the infrastructure business, and that's not necessarily where you want to be. So now if something happens with the server that this is running on, you're screwed. If something happens with, somebody updates the database, it doesn't quite work, and then you've got to rewrite that endpoint to work with a new version of MySQL or whatever the specifics of the incident are, that's now on you. So not only are you now responsible for making the game, you're also responsible for designing the SDK that sits inside the game client to talk to the database, and all the infrastructure that's going to capture that communication and shove it somewhere. So you've just increased the overhead of what you are responsible for, and when it breaks, you're responsible for fixing it. So you can do it yourself. There's nothing to say that you can't. Like I say, I have, but I don't recommend it for these reasons. But at the same time, like very quickly, you can get something very rudimentary up and running. that will do enough to get you where you need to go until it breaks. And then you can tell that I've got a little bit of PTSD around breakages in this system. But one of the things that we were able to do here with our own system, without any fanciness, without any of the clever tricks that I'm going to show you, what we were able to do is actually do some really clever, well, it wasn't clever, but we debugged a whole bunch of stuff. And one of the incidents that happened was we were in testing with a game we were making, and we got a little bit into this testing period, and we realized that all of the high scores that we were logging were massively inflated versus where they'd been, just a few weeks ago. And we didn't know what the hell had happened. Because we got the data, because we were logging high scores as part of our event counter system, we were able to kind of go back and look at when that happened. And it was something that we'd actually not noticed for about 10 days. But we had eventually noticed it, and we were able to figure out the exact day that that change had happened and the scores had got out of control. And then we had a date. So we have a date, we have a version control system, we can go back and say, okay, well, what happened on that date? And without really having to troll through our entire code base, what we found is that somebody had accidentally deleted the line of code that reset the level score counter at the end of the level. So instead of it being 100 points for level 1 and 100 points for level 2 and 100 points for level 3, we got into a situation where it was 100 points for level 1, 200 points for level 2, 300 points for level 3. So the moral of the story there is A, analytics can really help you with a whole bunch of different facets of this stuff. B, don't let the designers near the fucking code. So if I'm telling you that you shouldn't be doing it yourselves and you should kind of use something else, what is that something else? And I've picked here 3 analytics packages that I'm actually fairly fond of. All 3 of these have free tiers. So Unity Analytics, obviously, if you're in Unity, you can use that. If you're not in Unity, you can't use that. That's how that one works. But it's built straight into the Unity engine, so that's fantastic, and it's one click to turn it on. And the tool set there is actually very rich. Game Analytics is another vendor that is out there that you can use, another free tool. SDKs for Unity, Unreal, and a whole bunch of other stuff. And we'll be talking about their backend and their dashboards in a little minute. They're an interesting vendor in as much as they are pretty much exclusively free. So they're not kind of rate limiting, they're not feature limiting, they are giving you the entire of their tool set for free, because what they're doing is they'll actually monetize your data to third parties, which, if you don't mind that, is actually a good model for you as a game dev. And it also means that they have this really broad kind of cross-game insight into how people are interacting with games and moving around game ecosystems and stuff like this. And then the third one that I wanted to talk about is Delta DNA. This is a company based in my home of Scotland. Really smart, savvy company that's largely, I think, right now, I would say that in some ways they're on the cutting edge of the free tiers. They are, I believe they're rate limited. So as a small game, you can have a free thing. As you scale up, you'll have to start paying. It's fair enough, really. They have some great tooling around segmentation, around slicing and dicing and revisualizing your data. So those are kind of the 3 that I would encourage you to look at if you're kind of wanting to explore this further. Pretty sure pressing that button should have changed my slide. Okay, well, the mouse is still working. So, once you've integrated an SDK and you started logging event data in, you're going to get presented with something like this when you go to the web portal for whatever SDK that you're using. And this is part of why I say don't roll your own system, because you also now would need to develop an interface like this so that you could go and look at a dashboard. This one is, this is the Game Analytics dashboard for their demo app. It's showing what version of the SDK you're running on. It's showing, I can't actually read it on this screen. how many concurrent users you've got, hourly user counts, returning users versus new users. So it's giving you kind of a high-level insight into what your game is doing and kind of how people are interacting with it. And the how, a lot of the how is actually kind of below the fold. You get your top level of how many people you have kicking around very much at the top, and then you have to drill deeper to kind of get to that, how are they interacting. But it's all in there. So when we start talking about kind of this idea of logging events and kind of tracking users and all the rest, it's important to kind of take a minute and maybe talk about kind of some of the things that are fairly standard ways of thinking about and talking about kind of metrics and analytics. So I'm going to give you a whole bunch of jargon buzzwords, and we'll go through each one and explain what it is so that you're kind of a little bit better equipped to deal with marketing people when they start throwing weird random acronyms at you. So here you call KPIs. So KPI is key performance indicator. So right up at the top you've got installs. Pretty obvious, if somebody installs your game, they are an install. Here's a question for you. If somebody deletes the game and reinstalls it, are they an install or are they some sort of returning user? There is no right answer, but you probably ought to know which way it is that your SDK tracks that. Turns out that we use both ways at Zynga, so that's fun and something that I only discovered a couple of weeks ago. Daily active users, pretty self-explanatory. How many active users did you have in the last day? That's going to be a fairly volatile number day to day. Partly that's the seasonality of the week. More people play on weekends. So that's why you might want to talk about, instead of talking about DAU, you might want to talk about WAU, which is your weekly active users. So you're kind of smoothing out for that weekly seasonality. And then monthly active users when you just really want to talk about scale and quantity. And obviously, daily active users is going to be the smaller number. Weekly is going to be kind of bigger, but not necessarily 7 times as big because you have repeat users coming back. Same again for monthly. Lifetime value is where things start to get sticky. So lifetime value is about predicting, as a person has come into my game, how many dollars are they going to give me in the lifetime that they play this game? And we know that they're not going to play it forever, because that's just unreasonable. So at some point they're going to stop playing. How many dollars will they have paid me by that point? And anybody who has a definitive model on how to figure that out, please come and find me afterwards, because I think we'll pay a lot of money for it. There's a variety of different ways you can go about this. But at the end of the day, you have to know that number, right? And the reason that you have to know that number, I meant to change the order of these around. So we're going to skip over average revenue for a minute. We're going to talk about cost per install. So cost per install is the amount that you're prepared to pay in advertising in order to get somebody into your game. So you're going to buy an advertising campaign, maybe. As an indie, you ought to consider it, but you might be kind of ignoring it. Everybody who sees an ad is not going to go out and download your game. So there's going to be some conversion rate, and eventually you take the amount that you're spending on advertising, multiply it by the conversion rate, factor in a couple of other things, and that is the cost per install. And that's how much it's going to cost to get somebody into your game. Hopefully, that number is smaller than the lifetime value of a player coming into your game, because if not, you are screwed. So knowing those two values is super important to the health of your business, because at the end of the day, you shouldn't be paying more than you're going to get. The only way you actually figure that out is by knowing how much you're paying, knowing how much you're going to get. Welcome to the value of analytics. Average revenue per paying user and per user, fairly self-explanatory. And then retention. Retention is how many people are coming back to your game day over day. So at D1, that's the first day after they install. What percent of people came back? D7, D30, and then looking ahead, maybe D90, D365. D365 is a very aspirational one, and you would expect that it's going to be low, very low, but those people are so engaged with your game that those are where your super fans are, and that is why it's important to consider that.
When you calculate retention for, say, D7, are you calculating it based on anyone who has come between D1 and D7, or who has come
Okay, this sets up exactly the next paragraph, so thank you, Jen. There are actually two ways that you can go, well, there's probably a number of ways, but at Zynga there's two ways that we can go about calculating retention. One is the D model, and what that is specifically not who came back in that period, who came back on that day. So if I install on D0, and I don't play on D1, then I don't count towards my D1 retention, even if I come back in on D2. So that means that the D model of retention is not exactly the greatest that we have, because it misses people who just happen not to play on that day. There is another model that, frankly, I don't understand super well, that's based around new user return rate, current user return rate, and return user return rate, and we call it NURCR. Welcome to why I don't really understand it and don't really pay attention to it. But this is the kind of so if you have a new user, what is the return rate of that new user in that period, in the initial period? You then transition to being a current user, and what is the return rate of a current user in that period? If you stop playing for a period, then we classify you as a lapsed user, and you come back to the game, you're a returning user. What is the return rate of a returning user? It's probably going to be fairly low. We would hope that it would be much higher for the new users, and current users we expect to be what it is. So those are kind of the two models. Neither of them are super brilliant. One of them I can't really explain super well. But that's your KPIs. So that's kind of giving you insight into the business and kind of the top level of how you're going to do stuff. I don't know what the next slide is. Oh, okay. So you've got all your analytics now. You know when people start the game up. You know when they do things. You're going to log events. So events can be logged in different ways. But basically events are things that happen in your game that you think are important. So in the Unite talk on Monday, we were talking about level complete a lot. So as you complete a level, you log a thing into the database that says, this person completed that level. But it could also be fired a weapon, picked up a pickup. It could be died. It could be pretty much anything that happens that you think is important in your game can get logged. Kind of means that you're going to have a lot of stuff to wade through. The dashboards help. The dashboards give you pointers. The KPIs are fairly standard ways of calculating kind of business outcomes from basic stuff. If you want to go a little bit deeper, you're going to end up probably initially in Excel. So that's going to get pretty miserable pretty quick. But it is a viable way of kind of doing some number crunching, getting to some basic kind of stats and bottom line metrics around things that are going on. You get to a point pretty quickly, particularly when you're talking about kind of the amount of data that we're talking about here. So for the Unite talk, we were talking about level complete counters for 1 week. That gave us 163,000 users, 2.5 million level complete events. That was the download that I got from Unity was 1.2 gigabytes. You try and load 1.2 gigabytes into Excel, it's not going to be happy. And it's going to express that unhappiness by taking your machine down with you. So, probably need to go a little bit further than Excel. Here's one of the tools that I really love using and I advocate for on a regular basis. It's called Tableau. It's not free, unfortunately, but the desktop license is $35 per month per seat. If you work that out at an hourly rate of how much frustration Excel is going to generate for you, chances are it's probably worth having a couple of these licenses kicking around. The power of Tableau is that you can actually revisualize, slice data, do things in real time, explore the data, and kind of visualize in a variety of ways. So on the top here we have a progression funnel. So I talked about funnels earlier. So this is levels over time, or sorry, this is level increments by number of users who play that level in that week that we took a snapshot of. So in level 1 you have a lot of people and it's falling off, falling off, falling off. Fairly standard funnel shape. This one I think is amounted gold collected on each of those levels. We have duration of the levels, so you can see in general, higher levels are taking longer to complete. So this allows you to kind of just do, you would imagine that most of this would be built into the dashboarding, and in fact it is in Unity. I'm pretty sure it would be in the other tools as well. No, you should go away. Oh, Jesus. All right. Let's see if Google Slides will go ahead without Wi-Fi. But you can also visualize more important things or more intricate things. So this is, now Outlook is bouncing in the dock. Jesus. All right, let's see what happens if I do that and then that. This is what I get for not shutting everything down before I start presenting. Each of these is an individual data point of that level complete counter. It's colored by the level that got completed, and it is the duration mapped against the amount of gold collected. So I don't know exactly how many counters there are here, but imagine that there's probably somewhere north of 1 million being rendered here. Tableau will visualize this in about 30 seconds to a minute, something like that. It kind of has to have a think about stuff every time you change it around. But it's actually pretty slick to say how much data that it's messing with. So that tool is pretty powerful, and it's lovely if you need to visualize a lot of stuff, need to take pictures of things and kind of show people pretty graphs and say, no, look, here, here, here. But what if you want to go beyond analysis? What if you want to go beyond kind of just talking about what's happened? What if you want to go into, what can we do about it? So there's kind of a couple of things that we can do here. So at the Unite talk on Monday, and I keep referencing this talk so that I'm not duplicating for anybody who was at both, it was recorded, feel free to go and find it or find me after. We talked about clustering. So clustering is this notion of kind of grouping people together based on how they perform in game. And the example that we worked through was clustering people in 200 dimensions. It's really easy to cluster people in 2 dimensions, as smiley guy on the left there is highlighting. And in fact, in 2 dimensions, it's probably easier for a human to do it than it is for the machine to do it, given kind of the overhead of the machine. In 200 dimensions, I don't think I want to do that. And I would like the machine to just take care of it for me, please. And 200 dimensions is actually on the low side for this kind of thing. We weren't considering a whole bunch of other metrics. We were just considering level complete. So we got to a 200 dimension data set with just level complete data for 1 week. So that's clustering. Clustering is one of the things that you can do. Why do you want to cluster? Well, if you cluster people together, you can start treating them as being of a type. So if something works for that cluster of people, or they resonate with it, they like playing the game in a certain way, then anybody who's near them, who's clustered in the same way, probably is going to resonate in the same way as well. So that's kind of a way of understanding the player, understanding how they think, how they operate, and what they're going to like, and then being able to kind of surface that slightly different experience maybe back to them as a cluster. So that's why clustering is super important. But we can do some other stuff. And what we can do is we can use the past, what we've logged in the past, to predict what we expect to happen in the future. We can do that in a number of ways. But the thing that is really important here is, what if I could tell you today who of your new installs are likely to become payers? That's probably super important. It's something that you could act on. If they're never going to pay, start showing them ads. Because they're never going to pay, so stop trying to get them to pay. Find other ways of using their value. If they're never going to pay, maybe instead of giving them, here's a sale, maybe you should incentivize them with, hey, do you want some gems if you tell your friend about this game? Find ways that these people who are never going to pay can actually help your business. What if I told you I can predict who's going to leave your game next week? You think you could do something with that information? Maybe give them a nice little run of wins maybe, give them something that's going to make them more engaged with the game, maybe just tweak it about somehow. What if I told you that I could predict whether somebody was going to click on some dialog box and do something with it? The thing is that if you have your analytics all set up right, you can do those things, and it's not super hard. So the way it works, and it is as easy as this. People like me make it look more complicated, but really all it is you have some historical data about the things that happened in the game, and then you have a bit of less historical data about what happened next. So this person came into the game, and they did this, they did this, they did this, and then they left and they never came back. This person they came into the game and they did that, and then they gave us $100. So, by analyzing this window here, the historical data to predict and compare, what we can actually do is say, okay, all these actions are, all the people who did whatever the thing that we're trying to find is, all the people who paid, this is what the commonalities are. If we see people who are following these commonalities, there is a strong chance that they are going to go on to do this thing. Pay, click, leave the game forever. For fuck's sake. All right. Let's see if that will just leave me alone now. That's kind of all there is to it. So what you do here is you build what's called a training set, and also you hold some of your data out as a test set. Your training set has, here's all the things that happened, and then you label it by looking at the kind of what happened next. You go payer, non-payer, clicker, non-clicker, left the game forever, hate this person, whatever the label is going to be, you can put that in. And then you run some model training. And that could be a linear regression, it could be a logistic regression. There's thousands upon thousands of these different stats tools that you can use. And I'm not going to go through them all, because you know what? At the end, there's a website that I'm pointing you to where you can just find stuff. But the trick is, you train up on that data. Then you test it against a set of data that this model's never seen before, and you hope that it's accurate. And if it is accurate, what you do then is you say, okay, well, let's put this into production, and let's give it the recent data. Let's show it what people are doing right now, and let it classify those people. Let it put the labels in itself. Literally, that is 75% of data science right there on this slide that I just explained. Like, it is literally not rocket science. There's tricks to making it work. There's tricks to it working right. There's a lot of nuance. There's a lot of kind of sophistication in figuring out which model is going to be right in which circumstance. But this is what it boils down to. Like, it's not super, it's not hard. So let's imagine that we have a model. All right, what happens next? Because, as poor, starving, struggling indies, great, I've got a bit of math. How can I do this in such a way that my game is going to get better without it having to go through whatever ridiculous system Luke's got in his head? Let's talk about tech. This is what it looks like. And you've already got this piece, and I've just told you which 3 people I suggest you use for this piece. And they're doing this piece. All 3 of those vendors that I showed you will allow you to export that data down, so you can get a dump of the raw data. I think for Unity you have to pay, I'm not sure about the other 2. But you pull it down, you store it somewhere locally, and that could be a local file store. It could be name a database. My preference is MySQL, but I think that's showing my age these days, and I should be on some no SQL kind of thing. You could shove it in an S3 bucket. If you want to be really super clever and you've got oodles of money, you could start putting it into Hadoop, which is a parallel file system thing. But you don't need to do that. You could literally download it as a CSV, shove it on your file system, and work with it from there. And then you're going to have to load it in to some code and do something with it. Well, okay, so initially, like we said, that's going to be Excel. It's not going to be super great for you, but it's going to be that initial push to get some insights out. And then after that, you're going to start wanting to do more. So go to Python or go to R. So Python is a pretty good language for this kind of thing. Anecdotally, according to websites, it's now surpassed R for data science. R is a very statsy-oriented language. It's got a slightly weird syntax, but they are both fairly comparable, to be honest. And then if you've got a Hadoop system, then maybe, or even if you don't, you maybe want to do something in parallel, and then you might be looking at something like Spark, which is cluster computing, which, again, that's the high end of where you could go with this. You don't need to be there. Literally, you can do stuff on your own laptop. Just have a Python script, bring in the thing, train up a model, spit it out. And when you spit it out, you're going to need to put it somewhere so that the game can access it. You could shove it in a file. You could shove it in a database and build REST endpoints, and instead of sucking things down, you're pushing them back to the game. That's it. That's your data science infrastructure right there. You're going to bring it down from the analytics SDK. You're going to do the analysis. You're going to store whatever that label that, like, oh, this person is probably a payer, this person is probably not a payer, or whatever it is that you want to do. Could be the clustering thing. This person is this type of player. That person is that type of player. And then in the game, all you do is you write a bit of code that says, hey, go and ask the file, go and ask the S3 bucket, go and ask the REST endpoint that's sitting over the database. I have this user ID. What do you know about this user? Oh, well, that user is in this cluster. And then in your game code, you can do something about that. You can say, oh, okay, well, if they're in cluster 7, I know what that means. And I know that that means that actually I want to tweak this game slightly this way. Because these people want to explore the level. They want to find all the gold in the level. Therefore, what I actually need to do is give them slightly bigger spaces. Let's put them on this set of levels instead of that set of levels. Could be that. You know, it doesn't always have to be about monetization. Culturally, the way that I think about it tends to skew more towards monetization. But at the same time, it's really, there's two ways of looking at it, right? Analytics and data science is either about tricking people into giving you more money, or, and this is the one I prefer, it's about giving people a better experience and a more tailored experience and something that's going to be better for them as players so that they are incentivized to give you more money. Still kind of the same bottom line, but it's a different way of looking at it. So I'm kind of coming to the end of my time, so let's just wrap this bit up. So I've given you a very high-level overview of this architecture, so let's just dig a little bit deeper on what it looks like at the entry level. I'm assuming if you're a game developer, you have a computer. I don't think that one's a strong assumption. Grab a copy of Python, it's free. I tend to use 2.7, but you can use either 3.4 or 2.7. It's just different, slightly different syntax. You probably want a development environment. Could be PyCharm, that's my go-to as an IDE. Jupyter Notebooks is slightly more data science analytics-y and quite nice. And like I say, you need somewhere to stage your data for output. That's going to look like MySQL or pick a thing. And maybe you want to do a REST wrapper over the top of it. There's a Python package for that called Eve. There's probably about 500 of them. That's the one that came up at the top of the Google search. But it also looked pretty nice. So that right there are free resources that are going to get you this architecture. That's it. And then you say, oh, well, I want to do this thing. I guarantee if you put whatever you are trying to do with data science into Google, you will get a Stack Overflow article that tells you exactly how to do it. This is my career, is reading Stack Overflow and kind of figuring out what to do. Coursera has a couple of great data science courses that are going to kind of coach you on kind of the official ways of doing things. One of my big problems coming from an AI background and moving into data science was I sort of knew what I wanted to do, but I maybe didn't know the proper word for it. So something like a Coursera course will get you the proper word for what you're trying to do. And whatever you're trying to do, there's probably a Python package that can just take care of it. Pandas is one of the kind of staples that is very much on like data typing in a way that makes sense. So it's about kind of loading it. The core of Pandas is this thing called a data frame. It's basically a table, but it's in a way that everything will interact with. NumPy is kind of numeric operations and kind of clever numbersy, mathsy stuff. Scikit-learn has a bunch of models in it. Those three things are probably going to get you a big chunk of where you're trying to go, unless you're trying to do something exceptionally oddball. And yeah, I was talking with Perrin just yesterday, a couple of days ago, and one of the things that kind of that conversation has led to is, in terms of game development, data science, and analytics resources, there's nothing that great out there. There's no centralized hub or community. So come talk to me afterwards if you would like for us to get together and start looking at what an IGDA analytics special interest group is going to look like. Because I think that that's where this needs to go next for us as a community. And that will be a great resource that next year I'll be able to go, oh, you should just go to this website. It's going to have all the things that you need. So to summarize everything that I've said, basically, yeah, okay, the big corporations pioneered this stuff and we made it kind of look evil. Doesn't have to be. The tools have matured dramatically to a point where you can probably get up and running arguably better than some of the big corporations in a day, because you don't have tech debt, and we do. That means that access to all of this stuff has been completely democratized. There are so many services now providing analytics SDKs. There are so many libraries that will allow you to do the clever stuff. And frankly, there's platforms everywhere around trying to make this into something that everybody is using. There is no excuse as an indie for not taking advantage of this, of not kind of squeezing every little bit out of your game that you can. So please, please, please start doing this today. And if everything that I've said to you was incredibly boring because you knew it all already, we're hiring. So we're looking for analysts and data scientists, so come find me after the session. And then there is one last thing that is the final V2. The foundation, the IGDA Foundation, is an organization that I'm super passionate about and I've been involved with for the last 3 to 4 years. Many of you may know the IGDA here in Melbourne and around Australia. There's a lot of chapters, very active, great community here. The foundation is more on the charitable side. We do an awful lot of kind of community initiatives and things around the world, but what I want to talk to you about today are the scholarships, which you may have heard of. There's been an awful lot of winners in Australia over the years. We opened submissions for the scholarships at GDC 18 yesterday. That's for the IGDA Scholars Program, which is for students. Women in Games Ambassadors, which is for women who are kind of just looking to take the first step into their careers and looking for help and guidance on that. And Next Gen Leaders, which is focused on underrepresented minorities, kind of who've been in the industry for a couple of years and are maybe looking to take that next step into a more leadership role. More info at our website, igdafoundation.org. Deadline for that is December 8th. Did I miss anything on that one, Jen? Okay, excellent. So feel free to reach out to me. You can get me at ldickin@zynga.com, and feel free to tune in for my personal rantings at LukeD on Twitter, or check out my out-of-date website, or my out-of website at lukedickin.com. That's everything. Thank you very much. Yes and no and yes. So the system for doing that is this. I don't know of anything off the shelf that's going to give you that. On the other hand, I've not really been looking because I have all of this at my disposal. However, one thing that I will say is that every time we've done an analysis like that, where we believe that there are certain kind of stereotypical players, and we've gone out to find that behavior in our games, we have been incorrect to some degree. So I think that if you start from the assumption that you know what types of player you have, then you're going to end up not finding them.
Would it be fair to assume that even if you can identify that this persona is, this player is likely to not pay, for example, every one of them is going to possibly be parts of various personas?
It is to an extent, although the clustering stuff is intended to slice across the dimensions so that instead of getting a bit of this and a bit of that, you'll end up with this person, these people are this thing which includes yes, they'll pay. These people are this thing which includes yes, they'll pay, but they're both distinct types. The way that you surface it back and kind of action it is to put the clustering into your database or whatever thing, and then in the code say, when I see this type of person, what I'm going to do is I'm going to adapt in this way. When you're talking about a high-dimensional data set, actually figuring out what a noun is that you would put over that cluster can be tricky. It's not super obvious always because the machine has kind of grouped it, and it never kind of slices out equally as like, oh, there's a group here and a group here and a group here. You can definitely look at that as well. So this is drifting into what we would call segments. So segments rather than clusters. And if you want to know anything about segments in Unity, find the gentleman in the corner who was just walked in quite late to this talk, who is Mark Tannenbaum from Unity Analytics, who will be able to tell you all about how Unity does segments and talk to that particular piece. Up front.
Just in terms of the segmentation, because I'm involved in serious games and also in citizen science, and so we're kind of interested in doing that kind of segmentation about people's engagement in science and things like that, and then how to kind of cater to different audiences. So I was interested in the clustering and whether because usually with segmentation you try and get demographic information as well, because that has helped you to kind of identify those clusters.
Yep.
In terms of, so do you combine demographic, somehow capture demographic information?
So it's the unfortunate thing with demographic information is, well, kind of two or threefold. One is we don't always have it. Particularly at Zynga, we are generally encouraging you to Facebook Connect or Game Center Connect, but we also don't force that, so we have a lot of users who are just anonymous. What that means is that we can't rely on the access to demographic data. So it's unfortunate that we can't do that. On the other hand, it's not actually that big a deal, simply because the new EU regulations around GDPR, and I forget what that stands for, but this is basically a privacy thing. And basically what it comes down to is that personally identifiable information the user has the opportunity to remove themselves from any personally identifiable kind of stuff. As a consequence of that, that means that the demographic information is going to any that we have is high risk. So we kind of have to work from the assumption that we don't have it and move forwards. But I think there's a lot of things that you can infer. This is going to sound like a massive generalization, and it kind of is, but I believe it's true, that you can infer a lot about demographic data implicitly from playstyle. And because of that, you kind of don't actually, you feel like intuitively you feel like you want the demographic data, but I think that you get as much value from everything else because you can almost back from one to the other.
How do you balance the data collecting side of it, what you're actually collecting? Because obviously there's a bunch of stuff that you know
So, really great question. Here is my aspirational answer. Log everything. No, so there are two reasons not to log everything. One is costs of storage. So, you know, when you get to a certain scale, you end up spending quite a bit on kind of wherever you're storing that, however you're storing it. But as an indie, chances are that you're not necessarily going to get to that scale. The other reason not to log everything is the latency that it potentially introduces, since you're having to kind of go backwards and forwards logging those events. Unless those two things are actually causing you headaches, log everything. Because here's the thing, and you called it out specifically in your question, and you were quite right to, you don't think you need it today, but maybe you do later. And one of the big concerns that I have is I want to do an analysis in 6 months that relies on 6 months of data that I don't have. So I start logging that data 6 months from now, I can actually do that. So, log everything. Okay, that's time. So, any more questions, find me in the hallway. Thank you very much.